All right, hello. I just wanted to make sure that you know exactly how to do your homework. I know we wrapped up class for the biology section 1 a little quickly yesterday. So I just want to go through a couple examples with you so that you understand just some of the basic chemistry information and what you need to do. So if we look at the first part is looking at atomic information. So using the periodic table to figure out these other subatomic particles and information about the atoms themselves. So if you look, we have an example done for us. So we have sodium. So let's say it gives us the name sodium. We can look it up on the periodic table to get the symbol. Okay, the symbol does not always correspond with the English name of the element. Okay, sometimes it would more correspond with the Latin name for that same element. Then as we're looking through, we're trying to find the atomic number for the element, the atomic mass, then the mass number, which it says is just the rounded atomic mass, and then we're going to calculate the number of subatomic particles, so the number of protons, neutrons, and electrons, assuming that our atom is neutral. So let's take a look at our first question. Okay, so we're looking at this row right here. So all that it gives us is that our element symbol is H and our mass number is 1. So knowing that, we have to figure out the rest of the information. Now, of course, you're not expected to know this off the top of your head, and you have a periodic table on the back of your homework. So I'm going to pretend I'm flipping over the sheet, but I'm just going to scroll down. Okay, so there's my periodic table. So the first thing I want to know is, well, what element am I looking at? Okay. So if I want to look it up, I can look it up. You can also find a bunch of other periodic tables as well. If you look one up online, you might find one that's a little bit more comprehensive. So if you look, some of them actually have their names and some of them don't. So H, if you're unfamiliar with it, H stands for hydrogen. So I'm going to go up to the top and I'm going to add the name. So hydrogen, perfect. Oops, it's on cap locks. Oh well, I'm leaving it for now. So hydrogen, there we go. It says find the whole number given. So if we're looking at the periodic table where the H is, if we look, the whole number given on there is 1. Okay, so we're going to move back up. For our atomic number, we're entering 1. Atomic mass. So remember, the atomic mass might have a decimal place because it is an average. So this one says 1.0079. So if I'm, it's a little hard on my eyes there. So 1.0079, and I'll just add exactly what it is. So then we round it. So 1.0079 is closest to 1. And now it's our job to figure out the number of subatomic particles. So the atomic number always corresponds to the number of protons. So that is really the defining characteristic of any atom. So there we're going to add 1. Okay? So if the atomic number is 1, then there has to be 1 proton. Then the number of neutrons. So the number of neutrons we need to calculate. So we know that the atomic mass is just 1 unit. Okay, so atomic mass, that mass number is just 1 unit. So I'm going to take that 1 unit, so the total mass, and then I'm going to subtract the mass of the protons, because the protons and the neutrons are the only 2 particles that are contributing to the mass. So if I check the number of protons, I have 1 proton. So if I take 1 mass unit and I subtract that 1 proton, well, what do I get? 1 minus 1, so 0. So I'm going to type in 0, and my final mass is just 0. So I like the way it's set up there. It's a little bit more clear. So 1 minus 1 equals 0. So then our number of electrons. We said that we're always discussing neutral atoms. So if we're looking at neutral atoms, if there's 1 proton, okay, so that means that there's 1 positive charge within that atom. If we want it to be neutral, if there's 1 positive, then we also need 1 negative. Okay, so they've got to balance each other out. So that means that we're also just going to have one electron. All right, so let's try just one more together. So let's look at oxygen. So this time we're given the name oxygen, we're given the atomic mass as on the periodic table, and it's our job to fill in the rest of the information. So we're going to scroll down, okay, or flip over your paper, and we're looking for oxygen. So remember, you can look up a different periodic table with more information, or sometimes they allow you to zoom in, right, so that you can see all the little details. So here, I know that oxygen is O, so that's the symbol I'm looking for. So I'll scroll back up, okay, flip over your paper, and I'm going to type in O. So remember, the first letter is always capitalized, so you see capital O, capital H, and then a capital N and a lowercase a for sodium. So now, the next thing we're looking for within this row is the atomic number. So I'll scroll back down, and if we find the oxygen again, we see the whole number in the box is 8. So flip it over, and we're going to enter 8. So 8 is our atomic number. Then we're already given here our atomic mass, which is 15.999. So wrapped around 15.999, we should end up with 16. Perfect. Now it's our job to calculate our subatomic particles. So we got to do a little bit of math. And we always want to make sure that we're doing the calculations just to make sure. Okay? So our number of protons is always the same as the atomic number. So remember, that's our defining characteristic. That's what tells us what type of element it is. So here, if we've got 8 for our atomic number, we should have 8 again for a number of protons. Then the number of neutrons we do want to calculate. So we're going to take our total mass, so our rounded mass number, which is 16, and we're going to subtract the number of protons because that's also contributing to the mass, and we're going to end up with our remaining mass or the number of neutrons. So if we take 16, we subtract 8, we should end up with 8. Then looking at the next one, if we're looking at our number of electrons, remember electrons are negatively charged. So if we want a neutral atom, our number of negative charges has to be the same as our number of positive charges that come from the protons. So if we have 8 positives, we also have to have 8 negatives just to balance it out. Okay? All right. So I want you to continue from here. Remember, you need to try your best. Please don't look it up. Don't Google it. Just try to make sure you can interpret the information from the periodic table. And please remember, especially when you're looking at this next one, the atomic symbol or the element symbol might not correspond to the English name of the element. So this one might be a little bit tricky. Okay, but make sure that you're trying your best to calculate all the information on your own, and we will go over it in our next class. Okay, so now we're going to look at the second data table. So if we're looking at the second data table, we're going to do one of the examples together. So let's start with, we'll just go with the first one, H2O. So this is water. This is the molecule that we built in class while you were here. So if you're looking, we have our chemical symbol. We're trying to figure out how many elements there are total, and then how many atoms there are total. So remember, these little subscripts help tell us how many atoms there are of a particular element, so of the corresponding element, within that molecule. So first when it asks us, well, how many elements are there? Well, we know we've got hydrogen, and we've also got oxygen. Okay, so we can look those up, so the H for hydrogen, the O for oxygen, on the periodic table. So if we've got these two things, then that means our total is 2. So that's it. We've got 2 different elements in a water molecule. Now it's asking us how many total atoms are there. So this is where those subscripts come into play. So right next to the H, we see this little subscript 2, okay, on the right side. That's telling us that there's 2 hydrogen atoms within one molecule of water. So we're going to add that 2 for the hydrogens. Next to it, we see an O. So the O does not have any subscript. So when we do not see a subscript, so when we don't see a little number off to the side, we assume then that there's just one atom of that element within the molecule. So now we've got 2 hydrogens plus 1 oxygen. So that's going to give us a grand total of 3 atoms within 1 water molecule. So it's a very small molecule. So then you're going to continue. I feel like most of these will be fairly doable, especially after we looked at building them in class. The one I would be a little bit cautious about is this third one. So the third one, now it's saying we have Na and Cl. So remember, when we have these chemical symbols, these elemental symbols, they always begin with a capital letter, and if there is a following letter, they're always lowercase. So Na represents one type of element, and the name of that element is sodium. Okay? So just be careful, because this actually is capital N, lowercase a, capital C, lowercase l. Okay? Good luck!